Hi, everybody. We will start in a few minutes. Thanks for your patience. Hi, everybody again. My name is Martin, and I'm a team member of machine learning meetups in Bratislava. My today role is to announce our speaker, Ondrej Brichta. But first things first, welcome here at the 10th machine learning online meetups this year. It's the last one in this year, and right now we are hardly working on the meetups for the next year. If you have some free time next week, focus on the NERIPS meetup on Wednesday and Friday in next week. See the slides going on. For today, we have here a poll, and we would really appreciate your response. Now you have a few seconds to fill our questionnaire. So much thank you. In the meantime, we are here thanks to our partners. This year, partners of machine learning meetups are SAS, Konica Minolta, Seznam, Rosum, and Datacentrics. If you have any questions for the speaker, reach us at slido.com with hashtag MLMU. Questions will be answered after the meeting, and then we will try online networking in random generated chat rooms. Our main speaker for today is Ondrej Brichta, currently working as the product owner and the lead of R&D for machine learning at Minute.io. In the past, he was leading one of the AI teams in Exponea. Ondrej will talk about process mining and how can machine learning help with it. Ondrej, are you ready?
Yes.
Our virtual stage is yours. Thank you.
Okay, so I hope which screen I'm now sharing. Just a second. Should be this one. Yes. I hope you see the presentation right now. So thank you all for coming. My name is Ondrej. As you already heard, I work at Minute.io right now, which is a startup based in Slovakia. And we're already on the market for a couple of years. And we are right now like maybe the third or maybe the second in terms of the process mining like business sphere in the world. So our main competitor is Celonis, which is a German company, and they were basically the first one to start with process mining. So sorry, just a second. Yeah, so for most of you, the question probably is, what is process mining and why do we need it? So to answer it, first we need to know what is a process. So a process is something that repeatedly happens in a pattern. So if you have some, I don't know, like some e-shop or you are ordering something, or like somebody can order something from you, then usually when a new order arrives, you do something with it, like you first accept it, then you send it to somebody on, I don't know, in billing, that one sends it back to somebody in the shipping and so on, and then they expedite it, and so it's going to a courier and the courier gives it to you. So there are several steps along the way which happens, and they happen in the same or very similar order. And so the process mining is here to help people who have these processes to understand what is actually happening on the ground. So you can imagine that every or like nearly every software that is made for large companies, for example, like SAP or stuff like this, where you are doing some processes or like where you're doing anything work related, it's logging or tracking everything that you do. So, and from these logs, we can actually see like what is happening inside the company. So why do we need it is that people usually design, like the business owners usually design what the process should look like. So the way how I described you just a few seconds ago, that it's very smooth. There are like five steps included and nothing more. But usually the reality is way worse. So there is a lot of reworks, a lot of like loops back to the beginning, and so on and so on. So process mining is here for these processes that, like for these people that actually need to analyze their processes and improve them. So this is some sample log that we have from one company. And here you can see the most important things about the log are these. So it's the case ID. So the case ID here in top left corner, that basically tells us that, yeah, this, for example, is one order. So the 977017 is the just one of the orders, and it starts with start. Then it goes like actual process start, some status change or check order numbers, and so on, until we change the status to accounted, for example, and then the process ends. So this is one instance of the process. Then there is another instance of the process, so like process case. So this is the first case, this is the second case. And these are the activities that are happening. And this is the timestamp for each activity. And then here are some more data that we have about the process. That's not relevant right now, but will be relevant once we get to the machine learning part. So from this log, we can actually generate something like this. So in here, you can see how the actual log looks like. So most of the cases are going smoothly through. And you can see like this is the backbone of the process. So the cases actually start here, then they follow this path, or like half of them follow this path, but half this. There's only like a small change, and then they follow basically the same path. But for some cases, there needs to be like some shift to a higher level if it's not approved on the basic level and so on. So okay, this is something that was planned in the beginning, so it's okay, it's in the process. But for then also there are some other things that were planned in the beginning, so like the major paths. But then there are some things that we don't understand why are happening. So for example, why some cases end here in manual order number and so on, or why some cases go from here invoice accounting confirmation directly to solving a rejected invoice. This shouldn't happen. And so this is why we need process mining, so that we actually see what is happening on the ground. So now how to get from the log like this to a process graph like this? So the most basic algorithm, that is the first one to actually like open this scene, is the alpha algorithm created by Wil van der Aalst, which is a Dutch university professor. And he's basically the father of the process mining field. So the alpha algorithm, it starts with 3 basic rules. And these 3 basic rules can tell us a lot about the activities. So for example, these are like samples from a fictional log that is very short and very easy. And the process is also very short. So the first 3 instances are like A, B, C, D. Then there are 2 instances with A, C, B, D. And the last instance of the process log is A, E, D. So now we need to define with these three rules. So the two activities, like A and B are the activities, so A, B, or B, C here. So the two activities can either be independent, so they are never adjacent. They can show the causality. So B follows A, but A never follows B. Or they can show us that they're like parallel. So B follows A and A follows B. So for example, here C follows B, and here in the next process instance, the B follows C. So basically, they're just reversed here in the middle. So from this, we can basically create a metric like this, where we can find the connection between all of these 5 activities of the process. And so, yeah, it's very easy. Like the only parallel are C with B, and yes, the independent are, for example, A with D. So A is never occurring right after D or vice versa. And once we have this, then we can start the algorithm. So first we define all events. So that's A, B, C, D, easy. Then we define all possible start events. So in this case, it's only A. Then we define all possible end events. So only D in this case. And now the only hard part, or like semi-hard part in the whole algorithm, is like to calculate all possible sets A and B, where all events within A and within B should be independent of each other. And all events in A should be causally related to events in B. So that's basically sets like this. So here you can see like A and B is like, this is a pair of two sets. So the pairs in like the components in set A should be like causally related to the components of the second set, or the members of the second set. So we can see that, yeah, A has a relation with B, so that's okay. And the same with others. And then we also have like slightly larger sets here. So A has a relation with B and as well a relation with E. So the relation with B is here, the relation with E is here. And B and E have no relations together. So they're independent. So we can have a tuple of two sets like this. Now, so this is how we create all the possible sets. And then we drop non-maximum sets. So we are only left with those sets that can be combined from these small sets. And then the last piece of the algorithm is we will create places for all the derived sets and start an endplace and then draw the algorithm. So that's something like this. So we can see that this is the first set A, B, and E. So we have created this place here, B1 as place 1. Then for A, C, and E, so A, C, and E, we have created place 2. And for BE with D, we have created place 3, and so on. And now we can test if this resulted Petrinet we just created can actually, like if all the original instances here can actually be used in this Petrinet. So we see that we have like A, B, C, D. So A, then this goes in the same time. So A, B, and C basically in the same time. So let's say B is first here, and then D. The same with the second part, and then with just the E. So you go like parallel here, and then you meet in the E, and the same here. So you have A, E, D. So this is basically the whole alpha algorithm, which is I think the first process mining algorithms. But this algorithm shouldn't be used in real life because it cannot cover all the possibilities that we have. And also, like if you have some, for example, some noise in your data, or some XOR or stuff like this, then this algorithm cannot detect everything we want. So there are a lot of other algorithms on the market or like in the research that can be actually used for what we need. So I won't go into detail into that. So I just wanted to introduce to you what the first algorithm, which basically started everything here, is doing and how it's working. So you can, if you are interested, then you can study yourself. So now we have the process model. So what now? So basically, the job of the process analyst or a business process analyst is to analyze the model. Usually they are analyzing lab by hand, so they open the model and then they search like if what they see is actually what should be happening and what are the deviances and so on. Then they should like calculate inefficiencies. So or like we will calculate those inefficiencies for them. So we can actually calculate where the model has some loops or some reworks. So basically where something is being done 2 or more times instead of just passing through once. And then what we can do, or what they should do, the analyst, is to monitor. So like create some business rules and monitor those processes in real time. So that's what most of the process mining tools actually do. It's like those 3 things. I can show you how it actually works. So this is our tool, basically. This is from the same log I have shown you before. So here we can see how it actually works. These are all the numbers, like number of cases that have passed through and so on. So for like easily analyzing it, we can, for example, see where are the bottlenecks. So like the first bottleneck we can see is here. Like for those cases that are actually going for that need some more information, it usually takes 2.5 days. Or for some invoice accounting confirmation, that can actually take more than 5 days, or to solve a rejected invoice. So those few places, they take a lot of time, and that's the job of the business analyst to solve like why is that happening. So yeah, back to here. And so this is basically process mining. And now how can we as machine learning people or like data scientists help here? So the basic process mining algorithms, they only answer to the questions like what is happening right now. They don't answer to those questions like why is it happening and what will happen in the future, and or what would happen if I change something in the process. So the first thing, like why is it happening? We have like a root cause analysis, and this is basically something that is highly influenced by my previous years at Exponea, where I worked a lot with random forest and decision trees. And this is a custom implementation of decision tree with few minor changes, but quite important. So the most important change we have made, and that helps a lot, is that you can actually change the split to what you want. So as most of you probably know, regular decision tree algorithm works by splitting the data set until it meets the criteria of either the maximum depth or minimum numbers in minimum cases in one node, or some pre-specified threshold for Gini or variance. But we wanted to leave all of this to the user. And what normally happens is that you either have a Gini coefficient or a variance to choose the next split. And usually it's just like easy statistics, okay, I have the best Gini coefficient here in this split, and I will use that one. But what we wanted to give the user more power, and we created something where you can actually choose what should be your next split. So we have ranked all the possible splits and then shown the user like this is the best split that you can have on this data. But if you don't like that attribute, for example, because it doesn't give you any meaning from the business perspective, you can just select something else. For example, instead of cost center code, which has no business value to me, I can just sort it by supplier state or like split it by supplier state and then continue with my analysis. So this is how we basically can help the business people answer why is something happening in their process. And then the second thing we can do is to predict what is going to happen in their process. So they gave us the data, and so we can learn what happened in the past, like usual predictions, and then if our system is hooked to their database in real time, we can easily tell them like, okay, just watch out that, for example, this instance here is too slow, too fast, or whatever, like whatever business criteria you select, and so on. So from the point of machine learning enthusiast, so predicting something in the field of process or in the processes is actually very simple. If you are familiar with clickstream ML approaches, so to predict what would be happening on your website, for example, how would users click, that's also kind of a process. So it's nearly identical. The data itself, they have loads of categorical attributes. So we know about the process instances, where they're from, what is the, like, I don't know, if it's something that there are, for example, orders or something like that, then we usually know like what company is ordering, how much are they ordering, where are they ordering to, and so on. So these are all mostly categorical attributes. And for categorical attributes, from my experience, usually decision trees and random forest works the best, and it's also explainable. So it's very easy to explain this to any business person that, look, this is why your next instance will be late because of these 3 or 4 parameters put together. And it's also very cost efficient to train algorithms, like to train for this, because you only pre-process the data once, and then you can train all the models, like all the different business outcomes that you need to know. So the most common predictions for the new cases are like, what will be the next action? So for example, in if my process just started and there are 2 possibilities, either it will straight go to action A, or it will first go to action B, and then from there it will go to action A. I can have a model which will tell me, okay, like there's 30% probability that it will go this way. This is something that is extremely important to anyone who is working on the ground with the process, because they can interrupt that particular case or do something to like stop it or something like that. So, or we can predict the overall duration for the whole process, or the duration of the next action, and so on. So these are just the stuff that usually are predicted here. Okay, so the question I had about this was, can we combine all of these basically targets into one model? And what I found out, it's actually really easy. And there was some research done into this. So I came across a paper which was like a predictive business process monitoring with LSTM neural networks. And then I tried to replicate it. It was really interesting. And for those of you who are familiar with LSTM networks, I think it would be nothing really new, but to me it was pretty interesting. There were like several architectures that are tried. Some of them are here on the right, but what I found out is that the results are extremely similar to decision trees or random forests. So they also concluded it in the paper as well, that if you have a specifically trained model for each of the questions, then if you combine all of these models, then you will have similar results as with one LSTM model that tries to answer all of the questions. So yeah, you can save some time by training and then evaluating your data if you train the LSTM model, but you lose all the clarity or like the reasoning why something is happening in your data or not. So that's to predicting and so on. And lastly, the simulations. So this is something that I'm working on right now for the past month or two. And it's really interesting. And it's right now all the, like, for example, most of the researchers that are actively working on in the process mining sphere, they also stated that the simulations are, the predictions and simulation are right now the era where the process mining sphere should move. And basically, the point of simulation is to show what will happen if I change something in the log. So I can either remove any of the activities or add some another path from one activity to another, or change something. For example, if I have a bottleneck here, I can basically add more resources to that activity and see if it changes anything. So the simulation, in a sense, basically works by using a lot of randomness. So from the original data log, we will extract as much data that can be extracted about the process. So all the average waiting times, all the probabilities for the next activity, or the probabilities of the resources. So if I have, for example, 5 resources working on one activity, so that means 5 people on the ground, and there is a probability that, okay, like there is 20% chance that the resource number 1 will do this job, or like 50% chance that the resource number 2 will do this job. So we can just take all of these data from the original log and then simulate it really easily in cloud. And if we change anything in the settings, we can easily see that this should help me or this shouldn't help me. But the problem with this, it's that is still only random, and we cannot, like, if we want to change, for example, the amount of cases that come from one particular client or something like that, like we want to know if I have double the amount of some orders from a client from Russia, for example, there is no way to simulate it just like this. But what we can do is combine simulations with machine learning. And in essence, then we can do this. So the way how it's done is that in every activity that is in the process, we will create a machine learning model. Usually a simple decision tree or a random forest will do it. Especially there needs to be hundreds or thousands of models created. So something really simple is really good. And then evaluate for each node. We need to evaluate if from the data, if what was happening in the past was actually due to some randomness, or if it was actually something that we can discover. So let's say that from here, like this activity check whether the total approval, you can either go shift to higher level, or you can go to status change to approved, or something here in the bottom we can see. So there are three possibilities where we can go from this activity. And the job here, or our task here now, is to find out if these three possibilities are chosen by random, because this can happen in the process, that it's randomized, that whoever picks it, he will do the first task or something like that, or if there are some rules behind it. And usually the rules are connected to the attributes we have about the instance. So if we know it's from some country, or it's ordered, I don't know, the amount of the order is higher than some set amount or something like that. So decision trees are really good, or random forests are really good in finding these connections. So the easiest way how we are doing right now is that we will randomly split the data in this activity into train and test set, and then train the model. And if the model performs similarly well on the train and test dataset, then we say that, okay, this is something that is not random, and that is happening like because there are some actual rules on how this should be happening. Then we will keep the model, and then we will use the model in the simulation. If there is, however, if we find that the difference, for example, is more than 10% in most of the evaluation functions, then we will just discard the model and say, okay, like this is something that is random. So like the behavior in the original data was random. And so this way we can create models for all the activities. And basically we have right now we have three models for each activity. One model is telling us what will be the next activity for this particular instance. The second model will be telling us what will be the duration that the instance will be spending inside the activity. And the third model is telling us what will be who will be doing this activity for this instance. So which person on the ground, basically, because we have resources which are shared between activities. So we have actual names of people that were working on the activities in real life, and we have so the third model is telling us which resource, like which person is going to do the task in this activity. And yeah, so the whole point, like the simulation worked really good because of the randomness, and we wanted to keep the randomness in also if we are using the models. So basically how we are using the decision trees right now is that once there is a decision tree trained here, we are just like limiting the model to be trained only until like 3 or 4, like until depth of 3 or 4. And then yeah, I can show you. Yeah, so we have decision tree like this, basically. So this is of depth 3. And then I have like, in the whole process, I have 25,000 instances. And for example, like this is not model from the simulation, but there is very similar one. So if the instance in the simulation ends up in this node in the decision tree, then we will look at those 10,000 instances from the original data, and basically do the like we will randomly choose the duration to be like from one of these 10,000 or 11,000 instances. So without the machine learning approach in the simulation, we'll always just choose randomly from the whole set. So we have like 5,000 that, like if in here, if we have like 5,000 instances that are going directly here, then 10,000 instances that are going to manual identification, and 3,000 instances that are going here for demand for information. Then we would just randomly take it with the probabilities from these three basically things, like options. But if we are using the machine learning model, then we will first use the instance to get which node of the decision tree it will end up, and then from we will only get the prediction, like we'll only select randomly from those instances that actually ended up in the node. I hope you understand me, but yeah. No. Okay, and so the next step in simulations is to basically optimize what we can do with the process. So at first, we will need to find the bottlenecks. So for example, here there are two major bottlenecks and one, but whatever. It's much more than the others. And we will try to then, like, these can be found automatically. Then we have a heuristic that just proposes some changes to the graph. So I can either increase the resources for this, or do something else, like create another path between these activities that should like unload the instances from this simple path, and then simulate all of these changes like one by one. Then we can basically evaluate them, which one was, how was each one performing, and so on. And then in the end, we just show, we can just show it to the business user, so they can see and they can choose for themselves, like, yeah, this is something that I can actually implement in my process on the ground. So, and I see that it helps me to save like 10,000 euros per month. So then it's something that I really need to do. So yeah, basically this is all that we do right now. So thanks for your time, and now to the questions.
Thank you for your talk, Ondrej. It was brilliant. In the moment, we have no questions in the Slido. So all please ask if you have any question for now. Just post it to the Slido with hashtag MLMU. Maybe, Ondrej, I've got one question for you. What are the applications of process mining and machine learning applied to process mining? What are the typical case studies? What are the companies you are working with, and so on?
So usually it's like, it's our slang. It's like PTO or something like that. So it's like either you are buying something or you are selling something. That's are usually the two most common cases. So either you have like a system where you track everything that you have sold and how are you sending it and so on, or you have a system where, for example, you have a large company that regularly buys a lot of things, and you need to see how the shipments are going in. So if you have already paid for everything and so on. So these are the two most common use cases, but there are loads of others. Yeah, so basically it's anything where you can track what is happening to an instance and when it happened.
Thank you. We got two questions from anonymous users. First is, what are other fields than factories and companies where this approach could be used? Are there any?
I don't think so. It's mostly businesses. So if you are not a business or a factory or something like this, I don't see that much use cases for this, because this like process is something that repeats a lot. So there are like set of activities that repeats in usually in a given order. So if you don't have anything like this, or if it only happens like once or twice, then it's not usually a process. So yeah, we need some process that should be defined at least somewhere.
Do you have maybe some experience with warehouses, big warehouses, and optimizing processes there?
Honestly, I don't know. I can ask my boss, who is actually on this call right now, because he is more connected to the customers, but I'm not sure if he's listening right now. But I don't know, to be honest.
Okay, thank you. Next question. Do you have to pre-process the data from the logs, or are they always nice?
They are usually never nice. So I shown you a nice log so that you can easily understand it. I can show you a dirty log if you want. It's something that you really don't want to do, but this, if I can share my screen now. So this is how a dirty log looks like.
Okay.
So to analyze something like this, it's much harder than to analyze the log that I shown you. So that's why, like, analyzing this log by hand, if you don't have process mining, I think that will be nearly impossible. Even if you have process mining, it's challenging. And this is like the average log that we have. Okay. So I hope that answered the question.
Yeah, for sure. Thanks. The next question is from Kuba. Is it possible to handle the processes which go beyond the boundaries of the system you have logs from?
Of course, you need to join the logs somehow. Every system that you have has some ID for every instance that is going through the system. So if you can join them somehow to put it into one, for example, larger log, then this is possible. Most of our clients are actually doing this. So before they import all of the data into our software, they are usually pre-processing it, and this is the way how they do it. So they have some SQL commands or something like that that they are using.
This seems like something that could be modeled with Markov chains. Is there any model that uses those?
Well, basically what we are using is very similar to Markov chains. So yeah, that was my first question as well when I first saw it. And yeah, it's very similar, and it's like this alpha algorithm is slightly different because it can process parallel activities as well. I think with Markov chains, I don't know if you can do it. I think not, but if you don't have parallel activities, then yes, Markov chains are basically what we have.
What source was the most difficult to analyze data or processes from?
I'm not the analyst, so I can't really tell this. I usually just get some logs from our analyst and try some machine learning stuff on that. So I don't really know. Like for me, the one that I just showed you, that one was really nasty.
What is the most common mistake during process mining preparation? Probably the question is focused on struggling with preparation of the data with dirty logs.
That's actually, I don't really think that I'm the one to answer this question because I don't do this. Like I'm usually on the receiving end of the data. So I never really been with a customer that needed this. I don't actually participate in that part of the process.
And
maybe
we got.
I may interrupt. Hi, Ondrej. Hi, everybody.
Hi.
I was muted. Actually, one of the biggest mistakes here with the process mining data is that there is most of the enterprises just put everything in the event log. So they are creating huge amounts of data that will be unused in the analysis, and that's basically then creating the complexity of processing also with the process mining algorithms. It's kind of data lake approach, put everything into the lake and then do something with it. So
yeah, and then are you labeling the data, the all messy logs?
With most companies, it's kind of iterative process. So we start with the basic data set that's needed for the analysis, and then we are adding in iterations with the customer or with the business people from the customer side. We are adding attributes basically based on their questions or concerns or issues that they are trying to solve.
Mm-hmm. Okay, thank you very much. We got next question for Ondrej. What are typical length of processes? 10 tasks, hundreds, or thousands? What are the technical limitations? Can this be used to model, for example, customer behavior? Ondrej, you are muted. Sorry.
Sorry, didn't notice. Yep. So the typical length of the typical number of activities in the process is usually in tens or hundreds, and but the typical length of the process log itself, so the number of cases can be in thousands to millions. So it really depends. And for customer behavior, I would say it can be used, but you would the log would be really messy. So you would need to do something with it before you import it probably. But yeah, it can be used. I would actually love to see this because I've worked with customer behavior data before. So this would be really nice to see.
What methodologies do you use for cleaning up the logs? Did you try something that didn't work?
I usually don't clean up the logs, so I'm not the one here. Misho, maybe you can answer this.
Well, we are mostly using standard ETL platforms that are on the market. So I like talking from the practice with the proof of concepts that we do or from the project. So all the capabilities that they do or scripting techniques. So Python, SQL, whatever is available. There are some papers and research on kind of repairing the logs. So if you have missing values and you are using the rest of the log that is complete for example, filling in the empty values, but this is rarely used in practice. I don't know if that answered the question, but
I hope you did. Thanks.
Methodology.
Is process mining the only field your company is operating in? Could you build a whole business around process mining? Is it demanded enough?
Yes, I would say yes. Like in our company, it's the only thing that we are doing. So yeah, but we are still a startup. So we are not in the phase that we are actually earning more money than we use. But if you look at Celonis, for example, which is our biggest competitor, they are, I know their evaluation is in billions right now. So I think, yeah, you can build a pretty decent company just on process mining.
Another question about the logs. Were there any cases of log corruption, data corruption, or lost data?
Well, as Misha mentioned just a few minutes ago, there are missing data in the logs usually, so you can try to fill it in somehow. Yeah, if you like it happens regularly that some activities are not covered in the log. So then if you are analyzing the process, you have to somehow fill in the blanks, because that's very common.
Okay.
That's probably all that I can think of right now.
Ondrej, really much thank you for your today's talk. It was really brilliant and deep. Whole talk was recorded and you can reach it at our YouTube channel with the name Machine Learning Meetups. And right now we are preparing meetups for the next year. And one virtual applause for Ondrej, please. And now we can network in random generated rooms.
Yeah,
Thank you for your patience. Thank you.